Welcome back, and we are going to begin working on a few sections in chapter 6. And chapter 6 is all about rational exponents and roots. Rational exponents and roots. So rational, when we see the word rational, we should think of fractions, and exponents are that superscript up above. So that means we're going to have a fraction in our exponent spot, and then we're going to learn about roots. Okay. So the intro problem here is talking about ecology and conservation are topics that interest most college students. If our rivers and oceans are to be preserved for future generations, we need to work to eliminate pollution from our waters. If a river is flowing at 1 meter per second and a pollutant is entering the river at a constant rate, the shape of the pollution plume can often be modeled by this simple equation. And that says y equals, and that's called the square root. Okay, if you were to put that equation into Desmos, you could create this table right here and fill it in, and these values here, what would you would come out with the y for the width of the plume. The plume is the smoke plume that's coming out, those little like smoke cloud. And this is what the graph would look like. So we're going to introduce, most of us have worked with basic square roots before, but I kind of wanted to go over like their pieces and parts and what they are, and just kind of a different way to think about them, because I know it can get a little overwhelming. So if we were to go back to some of our basic rules of exponents, and we say x squared is the same as x times x, the 2 tells us that there are 2 x's being multiplied. Okay, we can also think of this in a little bit different way. We can think of this as x to the 2 over 1. So we can think of this as being a fraction. When we see 2, we don't really think of it over 1, but it really is. So the 2 tells us that we have 2 x's. We already know that. That means x times x. But the 1 in the denominator tells us that it only takes 1 to make a group. So we right now have 2 groups of x. Okay, so we're going to kind of think about that group thing as we move throughout the lesson. So let's look at one with just numbers. So we know from what we've learned in previous math classes in our life that 3 squared means 3 times 3. There's 2 3's being multiplied together. If we want to introduce this thing called a square root, a square root means we're looking for a number when multiplied by itself or squared, right? Something squared makes 9. So what number when x times x equals 9? It has to be the same number. So 3 times 3 is 9. So the square root of 9 is equal to 3. Okay. Going back to my group thinking, we can also say that 9 is to the square root of 9 is the same as 9 to the 1/2. Notice the exponent on the inside is the numerator of the rational exponent, and the root is your denominator. Okay, and I'm going to keep bringing this up. This means that I have 1 9, but I need 2 to make a group. Okay, but because we know that 3 squared makes 9, then we can say 3 squared to the 1/2, right? That's our square root of 9, is this. And then we can apply our exponent properties. It says a power to an exponent. So 1/2 power to the exponent is by multiplying them, which becomes 3 to the 2 over 2, which if we go by my definition up here, means that I have 3, I have 2 3's. Yep, I do. I have a 3 times 3, and the 2 in the denominator means it takes 2 to make a group. So I have 1 group of 3's. which is why the square root of 9 which is why the square root of 9 equals 3. Okay, so that's a square root. So let's look at a few other ones for a moment. Let's do another one. Let's say we looked at the square root of 16. So we're looking at two numbers. It has to be the same number, right? Multiplied by itself twice to get to 16. So I could say we've got 2 times 8, but that's not the same number multiplied by itself. We've got 1 and 16, but we also know we've got 4 and 4. So because 4 multiplied by itself makes 16, then we know that the square root of 16 is the same as the square root of 4 squared, right? Or the square root of 4 times 4. And so we have the 4 to the 2 over 2 because it's the 4 squared over 2, which means I have 2 4s and it takes 2 to make a pair. 2 over 2 makes a 1, reduces to a 1 fraction. So I have 4. The square root of 16 is 4. Now, most of us already knew the square root of 16 is 4, but there is a reason why it works out that way. So let's look at problem number 1 in our book. They want us to simplify. So we have the square root of 144. We're looking for a number when multiplied by itself twice gives me 144. Okay. So we can see lots of numbers, pairs of numbers that make 144. So 2 times 72, that makes 144. So we can see that 3 times 48, that makes 144. But it's not the perfect one. So on your calculator, most calculators have a square root button. If you have a graphing calculator, it is right here. It's the one that's the x squared key. You have to hit the second key first, the blue second key, and then the x squared key, and it will put the square root symbol there. And you can put 144, and it will tell you that it does come out to be an integer. Okay. Now, if I took the square root of 136, that is an irrational square root. It doesn't come out to be an integer number. Okay. So the square root of 144 is 12. If we want to take the negative of the square root of 49, it's going to be a negative, and we can check this in our calculator by putting second in the square root and putting 49, and that comes out to be an integer of 7. So this is a negative 7. Okay, now what if we had the square root of a negative 49? Because remember, a negative of the square root of 49 says that a number when multiplied by itself to get me this 49. Well, 7 squared is 49. The negative was outside of the square root. Can I have a number when multiplied by itself will give me a negative 49? No, because a number multiplied by itself would always give me a positive number. 2 negatives multiplied together would give me a positive, and 2 positives multiplied. So you can never take a square root of a negative 49. Now, in your book presents a great list that you might want to put on your note sheet for the next exam, so that you've got some common square roots, some common cubed roots. Okay, cubed root means that your group is a group size of 3. I'm not looking for pairs, I'm looking for groups of 3 of a number. So For instance, if I said the cubed root of 8, I'm going to list all my factors of 8, which would be 2 times 2 times 2. And my 3 tells me that I need a group of 3 to make a group. I need 3 2s to make a group. And so I have one group of 2s. And that's because 2 to the third, the cubed root, because 2 times 2 times 2 is 8, it's 2 to the third, the cubed root is 2 to the 3 over 3. And that rational exponent, that fraction, 3 over 3 is a 1, so it's just 2 to the 1. So the cubed root of 8 is 2. So let's look at number 9 from your book. Number 9 says, I want the fourth root of 16. So I know that 16, I can make it by a 4 times 4 if I want. But my fourth root tells me I need a group of 4. Well, I only had one 16, so that's not a group of 4. I have 2 4s, but that's not a group of 4. Can I factor? I can factor my 4s into 2 times 2, and then the other one is a 2 times 2. And now I can see that I do have a group of 4, right? I have 4 2s, so 2 to the 4th. The fourth root, this is 2 to the 4 over 4, which is a 1. So I know the fourth root of 16 is just 2, because I have a group of 4 2s. We can check this in our calculator. So there's the square root button, and then there should be underneath your math key. So your math key is right below your green alpha. There should be a cubed root, and then number 5 is an x root. So it will put it right here, and then you can say the fourth root there, and then take a right arrow, and it'll go inside the root, and you can put 16, and it will give you 2. Now, number 13 is the square root of 4 100ths, right? 0.04 is 4 100ths. And it's a square root. When you don't see the root, we assume it's a 2. And so I can break that apart and say the square root of 4 over the square root of 100. And I know the square root of 4 is 2, and I know the square root of 100 is 10. And then 2 over 10 reduces to 1/5, or 0.2. So number 17 says the square root of 36 times 8 to the 8th. So I can split this up and say square root of 36 times the square root of a to the 8th. And I know the square root of 36 is 6, because 6 times 6 makes 36. And 8, the square root of 8 to the 8th is the same as a to the 8 over 2, because it's a square root. And that evenly divides. 8 divided by 2 is 4. So this is a to the 4th. You're going to see more of these. 21. Again, we're going to write it as the rational exponents because it helps us simplify easier. X to the 3 over 3 and y to the 6 over 3. And I have an outside assignment that you'll see in Canvas that I'm asking you to do number 17 and 23, 84 and 86. And I want you to show your work like I'm doing here in the book and then upload. So x to the 3 over 3 is just a 1, so that's x. And then y is to the 6 over 3. 6 divided by 3 is a 2, so it's y squared. Okay. So 25, I can split each of these up. So this is the fourth root of 16. And then I'm going to write these as rational exponents, a to the 12 over 4 and b to the 20 over 4. And simplify my fractions. Now, we already know the fourth root of 16 up here. We did that. Fourth root of 16 is 2. So that's 2. And then the a to the 12 over 4, 12 over 4 is 3. So this is a to the 3. And then b to the 20 over 4 is 5. So this is b to the 5th. Okay. Oh, we have a bunch more we're going to work on. So, number 29, negative 9 to the 1/2. So on 29, they wanted us to write that into the root. 29 is asking us to write it in the appropriate root. So the 2 in the denominator says it's a square root. So it's a negative square root of 9. And then I think they want us to simplify and then simplify. So the negative of the square root of 9 is a negative 3. And then the 3 in the denominator means it's the third root of 8 to the 1. And then the third root of 8 to the 1, you can put that one in your calculator. So we can go to math. And Desmos has this as well. We can put 3 and then put 8, and we get 2. So 33 and 37. Go ahead and write those down, and then I'm going to go to Desmos so we can put these in 33 and 37. So 33 is a negative, and in parentheses, a negative 8, parentheses, raise that, oops, that should be an 8. We're going to raise that 2, and because my exponent is a fraction, I'm going to put that in parentheses so the exponent stays together. Okay, and you can see that's a negative 2. So you might be confused, like, hey, how can I have a negative number of a root? But we said only even roots can't have negative, cannot result in a negative. But an odd could, because you can take a negative 2 and multiply it by itself 3 times. So negative 2 times a negative 2 times a negative 2, and we get a negative 8. So odd roots work for negatives. We can also do this one by going down to our keyboard and doing the root. And you have to go to functions to get the different root. I think there's one here. It's down at the bottom under number theory, and it says nth root. So you can put 3 up there, and then in the inside you put a negative 8. Okay. So 33 is a negative 2. And then let's put 37. So 37 says, parentheses, 81 divided by 25, parentheses, and then an exponent. So shift in the exponent, and then you're going to put in parentheses 1 divided by 2 in parentheses. And that comes out to be 1 over 8, 1.8. Now, notice over here on the left, in the blue, I can click on fraction and have that put into a fraction. So it's 9 over 5. And that's because that's the same as taking the square root. So we could do the square root of 81 over the square root of 25. And that's why it comes out to be the same number. And you can actually do square root of 81 divided by, and actually individually to the square root of 81 over the square root of 25. And that's what comes out to be the same number. Okay. So let's look at 41 and then we'll take a break. 40, the last four on this paper. So 41 says, what about 27 to the 2/3? So 27 to the 2/3 says that I have two 27s and I need 3 in a group. So I don't have that, but I could break 27 down. So into other factors. So 27 is 3 times 9. So that's 3 times 3 times 3. And then the other 27 is another 3 times 3 times 3. So I really have 1, 2, 3, 4, 5, 6. I have 3 to the 6 over 3 because that's my denominator. And 6 divided by 3 is 2. So I really have 3 squared or 9. This is how you can do it by hand. Now we could do this in our calculator here by taking 27 and raise it to the 2/3 exponent, and it would tell you it's 9. So let's try that with 16 to the 3/4. So this is really the 4th root of 16 times 16 times 16. That's 16 cubed. And so I'm going to break down my 16s into, let's just see if we can do 4s for now. So 4 times 4 is 116, and 4 times 4 is the second 16, and then 4 times 4. So I've only got one group of 4 there. So I'm going to break these down into 2s. So this is really 2 times 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 2. And let's circle the groups of 4 because the 4th root. So 1, 2, 3, there's one group of 4 2s. There's another group of 4 2s. Yes, I got 4 groups of 4 2s. So this is 2 times 2 times 2 times 2. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is really 2 to the 12 divided by 4 equals 3. The 3 represents I had 3 groups of 2s. So it's 2 to the 3rd or 8. So 16 to the 3/4. Could have done that easy right here. 16 to the 3/4 is 8. All that work for that 8. 49 and 53 are reminding us that we could have negative exponents. A negative exponent means that it's just going to be in the denominator. So it's just 1 over, and then this is 81 to the 3/4. So we can put that in our calculator if we want. We could even put 81 to the negative 3/4 if we wanted to. But you could always do 1 over 81 to the positive 3/4, and you'd get the same number. Oh, sorry, you'd get the same number. 81 to the negative 3/4 or 1 over 81 to the positive 3/4 gives you 0.037. Now, if we do this in Desmos, it will tell us if there's a fraction answer available. So if we do 81 to, and then you have, this is the downfall about Desmos, you have to put this in parentheses. So it gives us the same decimal, but we can click on the fraction button. Oops, we can click on the fraction button right here. Oh, it tells us 1 over 27. That's the answer I would prefer. It's the fractional answer of 1 over 27. And then 53, let's do that one too. So 53 says parentheses 81 divided by 16 parentheses, and then raise that to the parentheses negative 3 divided by 4. And we get a decimal answer, but we're going to put it in fraction form right here. That comes out to be 8 over 27. I'll show you my paper here. So there's 49 and 27 and 53. So catch me back for the last half of this lesson. Just take a break and we'll be back for just a little bit more.